Yes. Hi everyone, I am SS Kiran. I am dealing course is electronic devices and circuits. Okay. In this course, I would like to discuss about problems on clamper circuits. Okay. Now let's start the first problem. Discover a diode clamper restore the bottom peaks of the input signal to zero level. Okay, use a silicon diode. Use a silicon diode with RF equal to 50 ohms forward resistance and reverse resistance RR equal to 400 kilo ohms. The frequency of a input voltage is, of course, it is the frequency 5 kilohertz. Okay, in this case, let's start the solution. So first keep a heading solution and write the given data also in your final examinations. Okay, first here we have to find out resistance. Okay, now resistance equal to root over forward resistance into reverse resistance. This is called total resistance. This is called forward resistance into reverse resistance. Okay, doing some mathematical part. Okay, this RF equal to 50 ohms and RR equal to 400 into kilo means 1000. Okay, so after that 5 fours are 20, right? Okay, just if you do all those calculations, that is around 14.14 kilo ohms of the total resistance. Okay, now as per the clamper circuit, there is a time constant is there that can be treated as a RC. Okay, okay, RC can be treated as RC equal to 20 T, 20 T. Okay, now here if you want to design any type of diode clamper circuit, capacitance finding is compulsory. Based on this expression, we can write the capacitance is C equal to 20 T by R. Okay, R already we find this R value, that is 14.414 kilo ohms. Now this expression again is converted 20 into what is the T? T can be write as 1 by F whole by R. Okay, then final, this C expression can be written as 20 by RF, 20 by RF. Okay, now 20 by what is the R value? R value equal to 14.14 kilo ohms into what is F value? F value equal to 5 kilohertz. So here I will write 5 into kilo means 10 to the power of 3. This kilo also I can write here. This kilo also I can write here. Now that is into 10 to the power of 3. Okay. Now doing all mathematical calculations of this C value, doing some mathematical calculation, this C value around 0.2828 into 10 to the power of minus 6. Okay, finally the capacitance value in the form of C 0.28 microfarad. Okay, this is repeatedly we can expect this one. Okay, this is the capacitance value. Okay, this is the determination of capacitance value of the given clamper circuit. Okay, let's start another problem. Okay, okay, right. Determine output voltage of the following clamper circuit. Okay, how it is clamper circuit? There is one capacitance and one diode and one resistance. Combination of these three components, we can design any type of circuit. Those circuits are called clamper circuits. Okay, this clamper circuit is essentially used for to shifting the DC level. Okay, now in this problem we have to find out output voltage. Okay, right. So for example, so first we have to calculate this is what type of clamper circuit, either positive clamper or negative clamper. Okay, let us consider there is a two conditions. Okay, there is a two conditions, right? This is note one. There is a two conditions. For example, if you apply the positive peak, what happened if you apply the positive peak? So this is the positive terminal and other one is the negative. This positive is connected to this cathode terminal. This is anode terminal. So this positive peak is connected to cathode terminal. In case one, what happened? In case one, this can be treated as a diode. Diode is, in ideal case, it should be, what happened? It should be open circuit. It should be a open circuit. Okay, so whatever given the voltage, input voltage, we can expect same voltage in the output side, which is having some shifting of DC level. For example, so here if you apply the positive peak, what happened? See, this diode should be open circuit. We can expect total voltage at the output side. So this can be treated as a positive clamper circuit. What happened if it is positive clamper? This is positive clamper. If you apply the input signal like this, we can expect the output signal is like this. Okay, this is the positive clamper. Okay, this is the level of DC. Okay, no need to write this reference level. Okay, this is the input waveform. This is the output waveform. Okay, so okay, anyway, whatever we can give the input voltage, we get the same output voltage here also. Then there is another condition. There is another condition. If you apply the negative peak, if you apply the negative peak, what happened? Diode is short circuit. Why diode is short circuit? This negative is connected to directly diode's cathode terminal. So what happened? Now it is the short. So once if it is short, I will redraw this circuit diagram with a neat manner. This is the capacitor. Once if it is short, okay, so this is reference voltage as it is, I will draw. Okay, this is the output resistance that should be treated as a R. This is capacitance. This is the input voltage, that is the V input. If you apply the negative supply, the diode should be short. So this is the 5 volts. Whatever we can give the input voltage, so it output is maintaining reference 5 volts only. So what happened if you give whatever the input voltage, output should be maintained only this minus 5 volts only. Okay, so based on our previous experience, what type of clamping this is? So positive clamping. So already 5 volts is maintaining at the output side. 5 volts is already maintaining at the output side. Remaining 35 volts is, we can observe here, that is plus 35 volts. Okay, how much? Plus 35 volts. Why? Because this is the positive clamper. 35 plus 5 is 40 volts. This is peak to peak voltage. 20 plus 20, so around 40 volts. Already 5 volts is maintaining the negative peak time, remaining 35 volts is maintaining the positive peak. Due to diode is open, it maintaining total voltage in this circuit. If you go with any formula, for example, if it is positive peak, if it is positive peak, what is the formula? V not equal to, there is two input voltages, one is positive, other one is negative, that is 2 Vi minus reference voltage, that is Vr. Okay, now what happened? So this is 2 into 20 volts minus VR, that is 40 volts minus 5 volts. So while applying the positive peak, we can expect 35 volts. Okay, so if you apply the negative peak, what happened? Only we can expect this 5 volts across this output side. Okay, now what happened? Circuit, the positive peak output voltage V not equal to 35 volts. If it is negative peak V not equal to how much? Negative V not equal to 5 volts. Okay, now again I will redraw output waveform with a neat manner, which will be very helpful for your end examinations. Okay, this is 35 volts and this is the 5 volts. This is the 35 volts and this is the minus 5 volts. So this is the positive clamper with reference, positive clamper with some reference, right? Okay, keep watching. I will update more problems. Okay, thanks for watching.